Great. Let's kick it off. So hi everybody. Thanks for being here, both in person and those joining us online. So we're going to be talking today about composable architectures. The title is Composable Architectures: The Good, the Bad, and the Ugly. I guess we're going to cover all of them. I have two great speakers or participants that are joining me here, and I'll introduce both of them first. Directly to my left is Krishna Chaparala. He is Director of Engineering for Solution Delivery at Madison Square Garden, which doesn't really need an introduction, but for the few people that might not know, this is, of course, one of the most iconic sporting and entertainment venues in the world. Krishna has extensive experience in architecting and developing technology solutions, having previously worked at PR Newswire and Progressive Insurance before joining Madison Square Garden around 5.5 years ago. Yep. Thank you for joining us. Mm-hmm. And next to Krishna, we have Mike Volozin. Mike is engineering manager at Boost Insurance, which is the leading B2B digital insurance platform that allows innovative companies from any industry to build, embed, and manage insurance programs for their customers. Mike is also a veteran of software development and architecture, having had previous stints at Teladoc Health and BCG Partners, as well as founding and later selling his own company.
Thank you for having me.
Thanks. And my name is Gijs Hendrix. I'm the head of product at Hygraph. Hygraph is the federated content platform that allows companies like Madison Square Garden and Boost Insurance and many others to easily manage their content and build great digital experiences. All right, so welcome, guys. Thanks for joining me.
Thank you for having us.
Great. So I thought we'd start with just getting both of your experiences on working with composable and microservices-based architectures. How you've seen this come up throughout your career, and what's your experience been working with these kinds of architectures? Can you kick us off, Krishna?
Sure. I think as Gijs said, I've been working in the industry for a good 16 years building software. Started off on monolith applications where everything is built on a single platform, so to speak, and we slowly, as we moved into a more agile world, or as you showed in your presentation yesterday, when we started working for mobile devices, we realized that if you want to be more agile, I think going through API first make more sense to do it, so that's how we started off. In the beginning, going on with smaller components that are being built new, we were trying to use them based on API. My example was like a translation service. We had to build a translation service for some of the content. We were like, you know what, let's use APIs to directly build a connection to the translation service and get them back immediately, right? So that's how we started off with APIs, made sense. Then we moved on to making API the center of everything. So that's how it all started off, working with DB2 mainframe systems all the way to serverless now with API-focused, API-first teams for me.
Makes sense.
I've kind of seen it go both ways. You know, there are organizations out there that are kind of pulling back a little bit towards monoliths these days, but even from like, if you look at it from a perspective of even a smaller, say, hobby type application, right? Somebody that would spin up a Create React app with some, you know, relatively simple API. But if they want to host images, they have to use AWS or Google Cloud. That in its own is a microservice.
Yep.
They want to add authentication to it. That in its own is a microservice. Yep. So, you know, you really can't get away from it these days. But at larger scale, and I don't mean large scale like your scale, but somewhere between a startup app and a publicly traded company, it certainly makes sense to keep things as a monolith, but just purely from a contextual, from keeping things combined by context.
Right, and that's a good example, right? Even if you have, like, for example, checkout, you're using microservices there, right? So we have Klarna, we have PayPal, Apple Pay, whatever you use. Even if it's a big application, you might not be able to get away from using an API, right, so to speak, in the architecture. So there's a space for both of them.
Yeah, I guess it's not a completely either-or thing, right? It can very much be an incremental change. Right?
Like they say, horses for courses, right? So what works for your business,
Right.
so to speak, yeah.
Yeah, it makes sense. And Mike, can you tell us a little bit about how this kind of architecture, what the current situation and the journey has been at Boost Insurance specifically, how you have it set up and how you got there?
So Boost has always been microservice oriented. I mean, admittedly, I've only been there for about a year. So the API was pretty mature by the time that I arrived, and my focus is on the front end team. However, when speaking with our CTO and other folks at the company, they told me that Boost, from its inception, has been microservice oriented and API first. But there are takeaways. Well, the main core of it is that Boost as a company is an API first company. So it was just a matter of us breaking things out by context internally. But the main takeaway that, kind of looking back on things now and having the benefit of hindsight and some growth, and we're able to say, like, maybe some things were broken out a little too much. Now, maybe we need to bring that back in a little bit. Or maybe there are other services that could be broken out into their own independent components and their own microservices. The journey has been that, it's been pretty consistent in that standpoint. On a front-end perspective, I've always historically believed in separating the UI from the API layer. And again, depending on what your perspective is, that could be a microservice of its own.
Right.
You have the web layer and you have the API interaction. We came in just immediately knowing that we want to keep these things separate.
Right.
But kind of taking that into account as well, we are using Next.js, which has a server of its own baked into it, has its own little backend baked into it.
Right.
So the front-end app is sort of like a monolith of its own, but it's still a microservice. So honestly, I don't even know what nomenclature to use for that anymore.
Yeah, and that underscores the point from earlier that it's we're mixing different concept, really, kind of makes sense. Can you, I guess maybe, Krishna, I'll start with you here. Let's talk a little bit about sort of the good side of microservices. What are your thoughts on sort of the business drivers for going to more direction of microservices and composability?
I think the biggest advantage is that you can focus more on the customer experience. On what I think it's always about what you're trying to optimize, what you're trying to maximize, right? If you use an architecture that will let you focus most of your energy on customer experience, right? And that's where I'm always trying to push for, depending on what business you are in. I think it's a B2B, it might be a little different, right? And direct to customer, it's a little bit more different because you're trying to optimize your customer experience and focus as much energy as giving the best experience for us, in our case, the fans. And then that's where having a microservices architecture helps, because you can scale things proportional to what we want. That's one thing I really like about it. Security-wise, I think you can be a lot more secure, just focusing, again, with the React front end that we have on our side. It uses APIs on the back end, so we're focusing more on the front end customer-facing stuff that brings more value. I think that's one of the advantages in my mind.
Makes sense. Was that something that within your organization was very clear from the beginning that you would be seeing those benefits?
Yes, I think as part of the digital transformation, we want to be as customer focused as possible, right? That's where our business values were, and that was one of the driving decisions for the architecture that we end up with.
Makes sense. And you're seeing those benefits today?
Yes.
Basically?
Yes.
Makes sense. Now, what's that been like for you, Mike? Is it the similar kind of drivers behind it for Boost?
So at Boost, our primary public API, it's just a single endpoint that we expose, because majority of our B2B customers are going to be API customers. They're going to be consuming a single endpoint. But underneath, we broke things up by, we have a bunch of different services, and the way that it was broken up is, it really was broken up contextually. And the benefits, on the one hand, are that you're able to scale things independently.
Yep.
And you're able to focus, whether it's people, time, money, whatever it is, you're able to allocate certain resources to the areas that need it. The one thing that I always try to, when I talk to folks that are either looking to build new apps, start from the ground up, is think about on whether or not you actually need that today. reality is most apps don't need to be broken up that way.
Yeah.
It's the one thing that I try to kind of instill in folks when I speak to them is to architect your app in a way where it would be easy to break out certain components into services later on. While we're not using Elixir at Boost, I've used it quite a bit over the years. The one thing that I've loved about it is it has a notion of context. So when you spin up, let's say, like accounts, users, for example, right? A user's model will belong to an account's context, so that at any given point, you could take that entire tree, so to say, and drop it into a different service. So as you're building the app, you already have that mindset of breaking things out and trying to keep things allocated in a way that would be easy to move around.
Right. Yeah, it's actually an interesting point that I guess the microservices and monoliths is also kind of a pendulum thing that kind of keeps going back and forth a little bit. But I get the impression that maybe nowadays there's so much more tooling and other stuff available, like you mentioned Elixir. But there's all these things that. Do you think that plays a big role in why these architectures are so popular nowadays?
Yes and no. I think a lot of it is also the literature that surrounds it.
Yeah.
People want to try. It's human nature. You want to try the hot new thing, the cool new thing. Microservices were cool. They became very popular. People want to jump on board.
Yeah.
The issue is you jump on board with a product, 6 months into it, you're committed. It's difficult to say at that point, you've allocated 6 months of work to an MVP, you've broken up into 100 different pieces. Now it's go live on that MVP, and you're like, oh, it really would have made sense to keep this as one item or one single API.
Yep.
But now we have a slew of feature requests for V2. Can we get back to re-architecting this? And it's difficult to piece things back it's more difficult to piece things back together than it is to rip them apart.
Right. I think I have seen this in my past as well, where we have broken down it into way too many parts, right? So I think what I've learned from it mostly is that you want to define your microservices based on your consumer. If you have multiple consumers using a service, I think that's a good use case to think of. Maybe this makes sense to make its own microservice. Because when you think about it, when you break it into multiple parts, there's an overhead to it, right? In the sense of, is it a different repo? It's as simple as it's a different repo. Is it a different job that builds it, right? What does it take to test it, right? I think there's a lot of overhead that comes with breaking a microservice into multiple smaller chunks. So I would say the thing I learned the most, and what I use as a rule of thumb, is to make sure you understand your consumers first and who's trying to use it. And that use it as start there and then see if it makes sense to break it up. Otherwise, as we're talking about, it can get very complicated, and you want a V2, and next thing you know, you're trying to think, does it make sense to put it back? Because this requirement needs to change in 2 different microservices. Right. And if it needs to be changed in both places, why did we break it again, right? So it is a fine balancing act, and something that you need to be really careful about, because it comes with a cost if you go too detailed into microservices. And I think going back to the other point, I do agree that some of the cooler I think, as you were saying, right, some of the cooler technologies make it enthusiastic to do these. Right? I think our API is completely serverless, but there's so many things that you could try with it that might make it easier to break it into much smaller components, but that might not be the best thing to do. Because when you're doing serverless, it's all lambdas, an API gateway for us when you use on AWS. So an API gateway can have a different lambda, and that's what makes it different, right? But is it necessary? Right? So it's a cost to benefit ratio, thinking about the roadmap, thinking about your consumer. I think it needs to be done very closely.
Yeah, so planning and architecting the solution is a really key element to making sure that you don't have to redo the work again, right? Which is always hard,
100%.
I guess, in any environment. To make a business case for doing a lot of re-architecturing, well, there's also business pressure on features. Is always hard.
Yep.
Yeah, makes sense. When you talk a little bit about we talked about these having all these different microservices, and then there's always evolution and stuff. But how does that play into this sort of orchestration and management of different services? Like, How much of that, for example, is exposed to the consuming applications? How do you see that?
Do you want to take that first?
Sure.
Yeah.
That brings its own challenges, right? So
Yeah.
now you're also looking at it from perspective of not only is it a separate service architecturally, but it's potentially, depending on your organization, also a separate department, because now you have DevOps very, very actively involved in your deployments. Whereas, a long time ago, engineers used to be able to just deploy their own stuff. And I'm sure in other organizations it's the same way. But as you break things out, now you have to worry about Terraform, you have to worry about, Kubernetes and all these other moving parts that an engineer, your front-end or back-end engineer may not necessarily have the exposure to it. So now, as an organization, you are now heavily reliant on another team to get something out. Now, I know it sounds like I'm kind of bashing microservices because I'm always adding a counterpoint to it, but that's not the case at all. There are absolutely benefits to it, but even what I just said, having a developed DevOps team is instrumental to an organization.
Right.
With that said, it's going to be, there's overhead in every sector of it. The one thing I'd like to kind of touch on, and to your point earlier with having a lot of different moving parts and a lot of different services, what folks don't look at early on is the absolute need, the paramount need of good logging.
Trace and logging, yeah.
If you're not in a position where you're able to trace the full life cycle of a request from the second it hits a user-facing app to every single back-end service that it touches, you're in a world of trouble.
Yep. So I think I agree with that. When it comes to orchestrations, there's definitely an advantage and disadvantage, just like how Mike was mentioning, right? The advantage is that if you have significance on security, you can just focus it at the orchestration level when everybody's coming in. So if you have multiple microservices, you have an orchestration layer, like API gateway, for example, you can have your security layer in front of it. That's one example, one good thing, right? If you need to maintain which users are using, counters, it's easy to do it in one place. But the disadvantage, again, when you have multiple APIs and you're trying to orchestration, is observability, as Mike was saying, right? Because when you have an issue, and especially if you have other services that you're trying to use, the biggest difficulty you'll have, I think the two of them, one is observability, and the second one is discoverability, right? When you have multiple microservices, it becomes, you need to be really good at discovering your own microservices. You need to be able to make sure that if there's a new pod being added in Kubernetes, it's able to know the connection strings, for example, in a secure manner, right? And that's another thing that is a challenge that we're trying to work through to get better at, but something you need to keep in mind. As you keep growing, as your microservices keep growing that talk to each other, both observability and discoverability are two things they have to be on top of your mind to make sure everything works seamlessly.
Yeah, it makes sense. So it's not like, the benefits don't come for free, basically.
Yeah, exactly.
You have to make sure that you have some of these other things in place to make sure that it actually works well. And what I found interesting, Mike, you mentioned like a DevOps team, for example, and the tooling that comes with it. So there's actually an organizational aspect really also that this kind of architecture requires something different from your teams in your organization, I guess, right? Are there more elements to that than DevOps? Does the work of your teams really change in this kind of architecture?
I think when we moved to serverless, I think that's when a lot of that changed in terms of a skill that's required, because you're not just writing code for a server or a Docker container, you're trying to write code that runs on a serverless infrastructure, like either it be Lambda, either it be API gateway. So it was unique in the sense that you're trying to implement serverless frameworks on your local to test these things to run on a serverless infrastructure. And even building them from a DevOps perspective, and I agree with Mike that you need to have a mature DevOps team to be able to do Terraform, for example, right, for the entire infrastructure. So it's a skill set that it's a combined effort between the developers and also a DevOps team to be able to do it. And yeah, so that's one of the things you need to keep in mind.
Absolutely. It's kind of a twofold process to your point where, you're breaking things out into smaller sections from a technology perspective, and you kind of have to do the same thing on a human perspective.
Right.
Good point.
Yeah, it makes sense. I guess the different, like you have the human side, the processor side, and the technology side. They all have to come together in this kind of setup. Yeah, it makes sense. So what role does GraphQL as a technology play in this this setup for you, your specific organizations, Mike?
Not much, unfortunately, not much as of yet. Boost has standardized on JSON API,
Okay.
and so that's where we're kind of using across all of our APIs. When we started building our front end experiences, we wanted to stay consistent with what the API is currently providing, because from the applications that we've built, we're also a consumer of the same APIs that our partners would use. Right. So we want to replicate that experience as closely as possible. Hygraph is really the only thing that we're using, that we're currently using GraphQL for. From personal experience, I've been using it for years. I absolutely love it. Love the composability of it. I love just the fact of being able to pull out just the bits that I need on the back-end side of things, connect the edges and the nodes the way that I need to. It's a lot more intuitive. It's just for where we are with the products at Boost right now, it's just not a priority. We just aren't built that way right now.
Makes sense.
Yeah, I think the thing I really like about GraphQL is the ability for the front-end developers to define and request what they want instead of having the API team try and build new APIs whenever they need something, for example, lighter, right? That's the beauty of it, and that's what we're trying to use. I would like to use to do so that we don't have 5 different services being called on a single page, right? Or making multiple calls for the same service. And all of them have a different levels of refresh rate, right? Some content is very static. It doesn't have to be requested refreshed every second. And some of the information needs to be refreshed every second, right? So that way you can just make one call, I think as you were mentioning, from the front end to GraphQL and fetch what the front end needs, just what it needs, right? And that's the beauty of GraphQL, make it lighter, especially, I think you mentioned this, all of this changed when the mobile phone came in, right? Especially on mobile phones, you don't want to have a huge JSON payload and try only pick 5% of it, right? And that's where GraphQL is very powerful in that you only call those 5 things that you need, and you're downloading a really small bandwidth of data, so that your pages load faster, you're not using a lot of bandwidth, and even if you're in the subway, it could work a lot quicker.
Makes sense. Yeah. All right, I think we've already covered a lot of sort of like tips and tricks and gotchas and things to cover, and like we have a couple more minutes. I do want to leave a little bit of room for questions. Are there any sort of remaining like things to be aware of for organizations that are really considering this kind of move that we haven't touched on yet that that are important to mention?
So that I really wish I could credit the source of this, and I read it on Twitter some years ago. I think it was Twitter, but somebody once said, debugging microservices is like solving a murder mystery, where in the end you find out you're the killer.
Right.
And there's a good amount of truth to that. And this kind of touches back on like the logging that I mentioned earlier, having good, mature logging, whether regardless of what platform you're using for that, but being able to kind of pinpoint where the issue is.
Yep.
And so that's going to be paramount. But at the same time, it will also give you visibility into an area of your infrastructure that you could scale.
Yep.
So the flip side is, the positive is that you could always scale things independently. You could harden security on independent parts. Mm-hmm. You could move things. You could swap them out. You could move pieces around independently without actually impacting your network as a whole. That's a huge benefit that people weren't seeing 10 years ago.
Right.
You're able to do real-time updates without any sort of planned downtime.
Yeah.
Huge.
Yeah.
But you have to be prepared for it on the human perspective and just understanding where you are. And a lot of that also goes into planning your architecture. Kind of thinking ahead of time of, do I want this part out? Maybe I'll code it in a way that I could pull it out later, but I don't need to today.
Yeah.
Yeah, makes sense.
Yeah, you need to have the maturity to do that, and I agree with Mike in the sense that scalability is one of the biggest advantages that we have, that we can horizontally scale components of your app that you might need. If it's event-driven, for example, right? The session before we were talking about doing authorization right? And those could be horizontally scaled without needing your entire app need to be scaled. Right? Back in the day, you either scale the entire application, including your database, or you could not. Like now, you can do parts of your application that you need. You can just scale them horizontally. That's very good, right? Observability, again, it is one of the things, until you get into it, you would not realize it. So you got to always plan for it. Right. Either the tools or there's another thing with microservices is that you get too much data, right? You get too many logs compared to a monolith application. And you need to find ways to have better logging structure so you can actually dig deeper quickly, right? Because when you're trying to look at logs, you don't have time, generally, right? All of us have been there where it's like you need to know immediately, right? So something you definitely need to plan for sure. And then work with partners or other systems like Hygraph, who you can trust, who are technology first in that sense. So that, because if you have multiple other components that you're building into your architecture, you're dependent on them for stability, for example, or services, right? So any SaaS provider, make sure the technology first, they have the same culture that you have, so that whenever you don't have any issues that you have to deal with, right? Because the good thing is somebody else is handling a component. The bad news is if they're not good at what they're doing, it'll impact your application. So that's something you need to be really careful about.
Yeah, makes sense.
Absolutely.
Yeah, so I guess, I mean, the summary is there's a lot of benefits in terms of scalability and flexibility and speed and developer experience and everything associated with microservices, but you have to be sure you know what you're getting into and plan and, plan for the worst kind of setup. Yeah, makes sense. Thank you both. Thanks a lot.
Thank you for having us.
Yeah, no worries. Are there any questions in the audience? Yeah. There's one in the back and I guess one in the front.
Yeah, I was a few minutes late, so I apologize if you already covered this, but when you go to a microservice architecture, eventually you need something to manage connections like a service mesh. I've heard some perspectives that some meshes out there are so complex that you just move the problem from point A to point B. Others argue you should be using something like Dapper that solves the problem at a higher level of abstraction than the network layer. Mm-hmm. Any thoughts on, what are your thoughts on how to approach this kind of problem? When should you migrate to a service mesh, or should you be using something like Dapper instead of a service mesh, and how to make that successful?
In my opinion, it depends on how many microservices that you have. If you have multiple microservices that are dependent on other microservices at runtime, I think a service mesh makes more sense, right? Because if you're trying to horizontally scale them, and if a new pod comes in, you need to make sure that the service mesh is up and it's able to get the discoverability of what systems are there. I think it all depends on how big how many microservices are dependent on each other. Does that make sense? And you had a question, sir?
Yeah, my question is, probably piggyback, you're saying, yeah, okay. The other thing is, business focus, right? And then if we look at the MQ series, the SOAP API, mm-hmm. So when we transition to microservices, you have the business requirements result, and then you test it out in parallel, and then you also formulate your best strategy to replace, the APIs, the modern API with
SOAP.
Oh yeah, the other API, the SOAP. Yeah. What, do you guys have a strategy for that?
I think my strategy has always been look at what you're trying to get in from a business context, right? Break them down based on the consumer. It's always start with the consumer. It's either the front end or a web app or a mobile app, right? Always start with that and see what are they expecting, and then break those down into different endpoints, right? And then make sure all your scenarios are covered using the endpoints that you have, right? And go from there and see what works. And this is where I think I like GraphQL a little bit. GraphQL, I think in this scenario actually makes a lot more sense, because you can have one huge endpoint, or actually, let's say it again, actually give all the information to GraphQL, and the front-end calling systems can request what they want, right? If they only want description, title, image, you can use the same endpoint, right? And if another system wants your pricing information, your calendar information, they can still use the same GraphQL endpoint. I think that way, we don't have to stress so much on getting the APIs right, because I've been in a place where you're really stressed out that you got to make sure you got the API structure right. And there were some great classes yesterday about that also to get them right in terms of what the naming needs to be. But you never know until you actually consumers start using it. And 1 year down the lane, somebody will say, oh, I like all of this information, but I need more information about X. So you're then going back into your API team and say, you know what, can you actually change the model on this to either extend the API, create a new endpoint, or have a new parameter, right? Trying to see what makes sense. But if you have something like GraphQL, your use case becomes a lot more easier. You supply that information, and it should work off the. But I think to answer your question at a high level, always look at what the consumer needs, and then based on it, you go back and create the endpoints, and then you go back to your business layer and say, you know what, which endpoints does the business layer fit in? Anything you want to add, Mike?
Yeah, I'll kind of just, echo what you said. A lot of it just comes down to really understanding, or even at a high level, understanding of or trying to foresee what your needs are going to be. We've all been guilty of prematurely optimizing. And that, when you take that into the context of breaking things out into microservices, that could lead you down a potentially painful and expensive path of, over-architecting. Historically, I try to follow the KISS rule. Keep things as simple as you can until that no longer makes sense. Just so use what makes sense until it doesn't.
And I really like what you said is, if you don't need it now, don't build it. Right? That's a good example as well, right? Because you never know how things change. And I think all of us have been in a place where you build something expecting X, and then one X never shows up, and it's something else when they want. So if you don't need it today, don't try to over-architect it. So
Makes sense. Thanks.
thank you. It's a good question.
Any other questions? I guess we're out of time also. Thanks, everybody. Thanks for joining. Again, thanks, guys, for a super interesting conversation. And enjoy the rest of the day.
Thank you.
Thank you.